Okay, everybody, welcome back. Hey, hopefully you guys got an opportunity to take a look at the last video, which was about plate tectonics and continental drift, where we talked about Wegener and some of those materials that we have here. What we're going to do today is we're going to get a little more in depth, a little more in detail about volcanism specifically. We'll touch on earthquakes a little bit. We'll talk about seismic activity and things like that. What I'm going to have for you here are a couple of things. Just like the last video, I'm going to have some notes for you guys you can follow along with and kind of go through. Anything in blue is a link that you can follow. Will be highlighted to some things, some information that you can get. I'll go over that in a little bit. We're going to use a couple of different resources. Google Earth, which I've set up a little preview kind of thing where we can go through and look at certain volcanoes that are located on the Earth. We'll zoom into that a little bit in a little while. If you guys recall back in class, I talked about Krakatoa, which was a very, very powerful volcanic eruption back in the 1800s. A volcano called the Child of Krakatoa, or Anak Krakatau, was erupting yesterday. So I thought it was pretty interesting. I figured I'd bring that up. I've got some information about cross sections of volcanoes and some websites that you guys will be able to use for that, as well as a really, really interesting website with the Smithsonian where you can go through and look at that. But first off, I wanted to kind of touch base about the Google Classroom. There were some questions this week about things to do, how to work on it, and things like that. So the assignment last week, and I'm going to reassign it again this week because we had a lot of people who didn't do any of the work this week, which for a variety of reasons would have been our vacation week and things like that. But I did have some people turn in their notes and their activities. So I'm going to repost the video. I'm also going to repost a little quiz that I want you guys to take on this particular video. So for those of you who have done the other work, the study guide, the review material, you're good to go. Just finish the little quiz. You can share it with me as a Google document or through Google Classroom. And I tried to answer some of those questions in a post up here. And then today I'm going to post, or tomorrow, more than likely on Sunday, I'm going to post this material for your next assignment for next week. And I'm going to put a 2-week window on here. Again, don't overly stress. I know you guys are going to be getting a lot of work from other teachers. I've got work up for every week since we started the COVID thing. So if you need some additional materials, you can go back and take a look at that and get those things done. So I don't want to take too much time about that, but that's going to be here. So you'll be able to access this here, and I can go in and view the assignments that are on that particular series of information. All right. So to go ahead and get started about volcanoes. So what I have here is a link to a Google Earth voyage, which you can click on here. You can click on this little thing right here, and it'll bring you to the link that I have up right here, which is 10,000 Years of Volcanism, which is put out by the Smithsonian Institute of Global Volcanism, right? So it gives you an idea of just active, or at least reasonably active volcanoes, or things that we monitor for activity anyway, around the world. So and again, so just to kind of give you guys a quick zoom in here, you can see obviously the Pacific Ocean is surrounded by this huge ring of volcanoes, hence the name Ring of Fire. You can see, if we go back to what we talked about last week with these plate boundaries, these subduction boundaries, we see huge volcanic island arcs from the Aleutians through Japan, through the Philippines, through the Marianas Islands, Micronesia, Indonesia, Papua New Guinea. We see all of these areas that are extraordinarily volcanically active. We've got New Zealand down here, and then even down in Antarctica, and along the kind of the spine, the Andes mountain range of South America. We can see that right in these particular areas here. So again, the Mid-Atlantic Ridge, we can see Iceland, we can see Vesuvius and the other Italian volcanoes right here. And then one of the volcanoes I'm going to talk about that I find super interesting is one called Erta Ale, which is located in Ethiopia. So we'll take a look at that one a little bit. But what we're going to do today is kind of just go over what a volcano is, what are the types of volcanoes, and we're going to kind of go through that cross section and go through this. I know the last video ran a little long, so I'm going to try to be a little quicker with this because I know you guys aren't going to listen to me for that long, but we'll go ahead and kind of hit the ground running. All right, so again, what is a volcano? You guys can take a look at this link. Again, underneath the Earth's surface, there's going to be a lot of hot material, and that heat is going to try to escape. Heat rises. Hot material tends to rise because it's less dense. Cold material tends to sink because it's more dense. And we're going to get these huge convection currents that occur in the mantle. And just like any other material, that material is going to want to get out. And so there's going to be areas along the Earth's surface where volcanic activity is going to tend to be congregated. Plate boundaries is going to be one of those things, and we'll talk about that in a lot of detail. But it's a conduit. It's an area where material can make its way up to the surface in those particular things as we look at that. Volcanoes, again, the word volcano comes from the Roman god Vulcan, whose Greek name was Hephaestus. He's the god of the forge, right? We've talked about that a little bit in class. I wanted to give you some information on that there. Volcanoes are kind of classified in three different types. There's active volcanoes, which obviously mean that we watch them for imminent eruptions or that they have been active recently. Dormant, which means they're sleepy. They're not doing anything at the moment. So we're monitoring them, but they're in no major way going to have an eruption anytime soon. An extinct volcano is one that we think is done. It's no longer going to erupt. So if you think back to the Grand Canyon material that we talked about, Vulcan's Throne was an extinct volcano that was located along the Colorado River in the Grand Canyon area. So this is another, again, so one of these words that we've seen here. So the types of volcanoes, there's three types, and I've added links inside of all this. 3 or 4 types of volcanoes. There's 2 major classifications that we're going to talk about. Volcanoes being openings in the Earth's surface. They can have mountains. They can be just cracks in the ground. It's places where either gases, lava, or pyroclastic material is coming out of a vent. So pyroclastic material can be anything from ash and tephra to gases, and even lava that can be coming out in these particular eruptions. So pyroclastic flows is another name of a downward movement of material down the flank of a volcano. So that's one of the words that I'll ask you guys to kind of make sure that you add to your FOSS notebooks as we move forward. Volcanoes are classified through a wide variety of different things, from height, from shape, from magma type, and eruption style, but there's 4 major types that we're going to kind of mention here. Shield volcanoes, these are going to be the ones that we see in Hawaii. So if I go over out here, we take a look at like Kilauea or Mauna Loa here. Let's see. I am not in Hawaii. Where am I at? I am in the Atlantic Ocean. All right, so back over here to Hawaii. Let's take a look. So Mauna Loa would be a great example. This is going to be a very low sloping volcano that we can see here. So it's going to be very shield-like. Mauna Kea is another one that we're going to see. It doesn't have that typical pointed top that we associate with volcanic mountains. It doesn't have that gapped cone at the top. You just have these big flat open areas where lava just kind of dumps out. And that's what we're going to see in these particular areas. So Hawaii is a great example of these shield volcanoes that we see these types of eruptions. And these typically occur in an area where we see hot spots. Composite volcanoes, composite means it's a mixture, right? So it's going to have it's going to have some lava eruptions, and it's going to have some tephra eruptions or some pyroclastic eruptions where we're going to see things like ash and things ejected from the cone. Mount St. Helens is a great example of this. Mount Shasta, Mount Rainier, Mount Hood, all of these Cascadian volcanoes that we see here in the United States, right? Crater Lake is a great example. We've talked about Crater Lake before. Mount St. Helens is obviously the one that we've talked about most in class here, but sometimes there's these huge eruptions like the ones that I showed you guys in class. Sometimes you have some relatively not so violent eruptions where you just have small amounts of ejected material from the crater. So composite means it's a mixture of shield volcanoes, and then the third type of volcano, which is going to be cinder cones. Cinder cones get a really, really classic volcanic shape. So if you're going to draw a volcano and you see that nice, even sloped sides that we associate with volcanoes, cinder cones are going to be the ones that you typically talk about there. Those are going to be located right along plate boundaries. Transform boundaries are excellent spots. Mexico has a ton of these types of volcanoes in those particular areas. And then there is a 4th classification, lava domes, which is kind of exactly what it sounds like. It's a dome-shaped area at the surface of the Earth where lava just kind of leaks out. And it's going to be very related to shield volcanoes and sometimes composite volcanoes. It's just going to be a vent where lava is going to kind of pour out. So the question here, where do volcanoes form, right? So we have hot spots, right? So if I go back to Google Earth, let me zoom back out and actually go to Hawaii this time. We have this here. So hot spots are actually, shield volcanoes are going to occur in this area, like right in here, where there is no plate boundary. Right, so this is located right smack in the middle of the Pacific Plate. Let me get rid of my mark here. So there is no plate boundary here. So there has to be some catalyst for this material to come up. So what we have is, again, a huge convection current in the mantle where there's really, really hot material, and it's kind of just burning its way through the crust. So this particular area here that we see is going to be an example of a hot spot. So any area that's away from a plate boundary almost exclusively is going to be hotspot volcanoes. So right here, Yellowstone up in here is going to be a hotspot volcano. There's some more that are located over in the Eurasian plate that we can take a look at. But these are going to be areas where material kind of just bubbles through, burns through the crust, and erupts. Now, when it happens in the mountains, when it happens in the ocean, you get some really liquidy lava that creates these really nice shield volcanoes, these large sloping shields. Imagine Captain America's shield on its side. That's kind of the shape that you're going to get here. And again, Yellowstone, we've talked about Yellowstone a lot in class. It doesn't even look like a classic volcano in the sense that it's huge. It's 18 kilometers across. So, we're looking at 10 or 11 miles across. If you were standing next to it, you would have absolutely no idea that you were looking at a volcano. It's just a huge area where that material pops out. The last volcanic eruption out in Yellowstone, if memory serves, was around 1350 BC. Let's see where we're at here. That's too far south. Jordan craters of the moon. Here we go, Yellowstone. There we go. I thought it was right there. So Yellowstone, 1350 BC is going to be the last eruption that we saw here. And again, 16-kilometer wide caldera that's located in the actual Yellowstone National Park. There are multiple calderas that are located in those national parks. All right, so back to the notes so we can kind of move through this. Volcanoes are important for a number of reasons. They're going to be an agent of change on the Earth's surface. They can be both constructive in that they build new land. They can be destructive, obviously. They can blow things up. They can reshape the area in which they're surrounded. And they're going to cause lots of those particular things as we study them. We can see that. Another reason they're important, obviously, is because they're going to be where magma turns into lava and comes pouring out in the Earth's surface, where new types of rock are going to be created, right? So when we take a look at magma, we note that it's made out of a lot of materials that we find in the Earth's crust, which makes sense because whenever the crust gets pushed back underneath other plates at plate boundaries, that crust is going to melt and it's going to turn back into magma, and then it's going to make its way back up towards the surface. So we see elements like oxygen, silicon, aluminum, and iron, right? So you guys saw the big basalt chunk that I have there. It's got some iron in it. Sodium, magnesium, potassium. These are all relatively common. Oxygen, silicon, these are super common materials that we find in the Earth's crust. And in particular, when we look at silicon, this is going to have a really, really important effect on how lava moves and how volcanoes behave. If you've got a lot of silicon in your magma, it's going to be really sticky. You're going to tend to have really explosive eruptions. If you don't have quite as much silicon in it, you're going to have more runny lava. Think of like a runny egg yolk kind of eruption. Those tend to be less explosive, but you're still dealing with material that can vary in temperature anywhere from 15 or 1600 degrees Fahrenheit up to about 2000 degrees Fahrenheit. So still, regardless of the type of magma, they're still dangerous, but one is much more explosive than the other. Volcanic rocks create igneous rock, right? So this is kind of one of the things that we were talking about from this. Igneous is Latin for fire formed. That's where it kind of comes from. There's two classes of igneous rock. There is extrusive rock, which forms externally on the Earth's surface. That's where that word extrusive comes from. Let me go ahead and bold that for you guys before I forget to do it. Extrusive rocks are created when lava or the pyroclastic material cools at the Earth's surface. So magma, or lava pours out of a volcanic vent on Mauna Loa. It solidifies, it creates extrusive igneous rock. Intrusive rock is whenever those volcanic vents, the lava doesn't make its way all the way up to the surface. So the intrusive rock forms on the interior of the Earth's crust. And when it does that, it's going to cool below the surface of the planet, and it's going to create, typically we're going to see a lot more crystalline structure inside of that. It's going to cool off much slower, and that's where we're going to get lots of the gemstones that are pretty highly sought after are found in these magmatic vents, these intrusive deposits that form in old volcanoes. Diamonds would be a great example of this. So what I have for you guys here is a series of vocabulary words. I'd like you guys to look these up. You can use Wikipedia, you can use Encyclopedia Britannica, you can use Google, whatever those things that you wanted to use here. Add those words into your FOSS notebook or put them on a Google document. And then what I did is I included a huge amount of little videos and interactive materials that you can work on. So to use these, click on the link. It'll bring up the little link here. You can copy and paste that up into your browser. Actually, you can just click on it. It ought to bring you directly to that. So we've got some volcanic stuff, we've got some of this, and what I would like you guys to do before you answer the questions below is I've got a little Mount St. Helens video, and I think this is the one I showed you guys in class, but I want you guys to rewatch it, and then you're going to answer these questions on a Google document with me. So you can copy and paste these onto a fresh document. That is totally okay. So the 10 questions are listed here. I've got 6, and then I've got 4 pretty big follow-up questions that I want you guys to answer. These are going to be the much more open-ended, critical thinking questions that I'm going to take a look at to see if you guys can kind of or have a better understanding of the material itself. As always, I wanted to give you guys a list of resources that I use to put this together. So these are located down here. You can certainly go click on that as we do that. Now, we're at about 15 minutes here, so I want to don't want to hold you guys up too long, but I'm going to show you a couple of the other things that I found pretty interesting as we talk about these volcanoes. So again, go through, take a look at these notes, and make sure you add this material and answer these questions into your notebooks. So again, from space.com, this is Inuk Krakatau, which is a pretty interesting volcano, extraordinarily eruptive. It's located that'd be northwest of the Australian coast in the Micronesian Islands, the Indonesian islands. And this is taken from space probably 2 days ago. So that would have been April 16th. You guys could take a look at that. So this is located on that space.com link that I showed you guys. Here I wanted to show you guys just kind of a basic cross-section of a volcano. This is NOVA, which is put out by PBS.org, which is the public broadcasting system. So it's not super fancy, but you guys can see that this was put together back in 2002, so it's actually older than you guys. But again, for a cross-section, I thought it was really good. It talks about where the ash is located. Let me get my little pen here and get my pen down the side. Oh, wrong one. So we've got ash, we've got lava flow, we've got lava domes. We can talk about that. We've got the magma reservoir, the magma chamber down at the bottom. We've got fissures and vents that are coming out off to the sides here. So these are all going to be things. And this would be a classic example of a composite volcano. So you can see this layering that went into creating these particular types of things that are located there. So I wanted to show you guys that so we can take a look at that. So again, this website is going to be on there as well, so you can look at it. Again, this is the Mount St. Helens eruption from 1980, July 1980. So you can take a look at that big eruption. I've showed you guys that before. I thought this was pretty interesting. It goes into lava flows and ash flows. In Japan, you can see halfway up their door here, the ash is solidified into almost a concrete-like material. Fields of lava that poured out of this. Lava domes that are created. You can see the cracks inside of this particular thing here. This shows us that it's cooling off. This lava dome in particular is in one of the vents in Mount St. Helens. Lava, again, just really cool to kind of look at. A vent is going to be that open area where material is being released from the interior of the volcano. Tephra is going to be very much pumice, right? So pumice and scoria are the rocks that we talked about in class. They're created from volcanic rock and lava that cools off in a slightly different manner. And it creates these large masses of this material that's typically pretty airy and light. So tephra is going to be one of the things that we see here. A caldera is that whole crater-like shape, that central depression on the inside of the volcano. A lahar is another name for a pyroclastic flow. It's when all this material runs down the side of the mountain. So you guys can go through on the NOVA website and take a look at this. Again, I added this link for you. Erta Ale, I wanted to show you guys, this is one of the coolest looking volcanic eruptions that you can see here. It's an open volcanic lake. So at any given time that you go there, you're going to see these huge amounts of lava that are just kind of sitting at the surface. So they have these small eruptions. This material gets shot out. So you can take a look at these boiling lava pictures here. So this kind of gives, this is not, CGI. This is not computer animated or anything like that. These are true volcanic action pictures that we can see at Erta Ale, which is located in Ethiopia. And I'll zoom over onto Google Earth here. Whoop, I went way too fast. So Erta Ale is going to be located in the Ethiopian region here in the central eastern part of Africa. Okay, so I thought that was a pretty good one. VolcanoDiscovery.com shows you the currently erupting volcanoes. So we've got a couple of them that are erupting in Central America. We have some on the spine, the Andes mountain range here. Erta Ale is erupting. It's always erupting virtually in Ethiopia here. Stromboli and Mount Etna, which is located in Italy. Stromboli is a really, really interesting volcano. It's got a lot of historical importance to ancient Greece and ancient Rome. It was certainly a catalyst for some changes that went on in those areas. And then again, on the opposite side of the ring of fire here, we see some additional volcanoes along the Japanese islands, near the Russian Aleutian Islands here, and then Indonesia and those particular areas here. So that's VolcanoDiscovery.com. The active volcanic map, I guess I could have brought this one up here. Mount Erebus, located in Antarctica, is erupting. It's still very active, so we can see that here. And just another really cool website you can go to is the Smithsonian Institute volcano website. So volcano.si.edu. Again, it's located down here on the bottom of the worksheet that I gave you guys. So you guys can click on that, volcano.si.edu. This one here it shows you recent volcanic pictures of activity, Indonesia, the United States volcanoes that are located in the Aleutian Islands that are erupting. And it's got some frequently asked questions, right? So how many are active on the Earth? Between 40 and 50 at a time. Have we seen volcanoes increase, the activity increase on our planet? No, it's right on average for what we typically see. And there's plenty of information about materials going on around the world. So it's certainly one that I would encourage you guys to take a look at. And there's some web applications you guys can go play around with here. If you see this little map that's kind of hard for us to bring up here, let me see if it'll actually bring up for me. This is a great example of plate boundaries. So you can see all this volcanic activity that is occurring along these light blue lines. These are volcanic vents, right? And volcanic areas of activity that we can see here. So certainly a really good thing for you guys to take a look at. So just in closing, I'm going to post this on Google Classroom on Sunday. So you guys will be able to work on this throughout the week. You're going to have 2 videos to watch. If you haven't done the one from last week on plate tectonics, do that one first and do the little quiz that I'm going to post. And then I'm going to post the volcano one, which is going to have a little study guide just like the one from last week and a little quiz for you guys to work on. So that being stated, if you guys have any questions, send me a message through the Google Classroom. It's new for me as well, so definitely be patient while I'm trying to get to those questions. And if you have any interesting things that you want me to kind of talk about, yeah, let me know. I will certainly do that. We're going to talk about earthquakes next, so that's going to be the last natural disaster that we're really going to take a look at. And then we're going to move a little bit more into mitigation, how we tend to try to build around these particular things. So I hope you guys are doing well. Hope everybody's healthy and taking care. I know that it'd be really easy for you guys to just say I'm done and not really do any of this work. But, you know, again, bottom line is I want to make you guys as prepared as you can for Terrebonne next year. So stay tuned. I'll put some new stuff out every Sunday for you guys to kind of work on. I miss you guys. I hope you're having a good day. I hope you're having a good week. Be safe. All right. Have a good one.